Okay, good morning or good afternoon, everybody. Hope you guys are having a good day today. I want to go over equivalent ratios and then some unit rate. We're kind of starting off our curriculum with rates, equivalent rates, unit rate, and then we'll talk about rate of change and things that have to do with that. So we're going to start with equivalent ratios here, and make sure you should have something to write with. Hopefully a pencil, could be a pen, but hopefully it's a pencil. And then a composition notebook or a spiral notebook, or if all you have is a scratch sheet of paper, you could use that too. It'd be better to have a spiral notebook or a journal so you can keep it organized, but something to copy these notes down here. So I'll kind of talk about, you won't need to copy down everything, but I'll kind of tell you specifically, but have that there so you can copy it down, and then there'll be some questions for you to do after you get through this. So equivalent ratios, you can kind of title that at the top of your page, equivalent ratios. And you can always pause this whenever if I'm going too fast and write something down, and then unpause it to kind of get yourself caught up. So you don't need to write all this down. We're just going to talk about a quick little warm-up scenario with equivalent ratios. But pay attention, we'll talk about how equivalent ratios work, and hopefully this will sound kind of familiar. So this says, looking at our scenario here, Elena mixed 2 cups of white paint with 6 tablespoons of blue paint. Great. Question part, or the statement here, read and think about each statement. Select all the statements that correctly describe this situation. Okay, so we know the ratio right now is that she's got basically 2 cups of the white paint go with 6 tablespoons of the blue paint. So basically like a 2-to-6 ratio. Remember, you can write ratios. They can look like a fraction, or you could write them with a colon if you want, or you can just write the word 2 to 6, something like that. My 6 isn't perfect there, but you guys get the gist of it. Okay, so that is our ratio we're working with. So let's go down and see what our true statements are. A says, right over here, the ratio of cups of white paint to tablespoons of blue paint is 2 to 6. Well, yeah, I think that checks out. That works, and we already wrote it down. We said it was a 2 to 6 ratio, so that works out for me right over here. B says, for every cup of white paint, there are 2 tablespoons of blue paint. Well, for every 1 cup of white paint, there looks like there's actually 3 cups, not 2. So I don't like that statement. That doesn't work out, and I'm not going to pick that one. That would not work out. C says there is 1 cup of white paint for every 3 tablespoons of blue paint. Like that one better because I see my 1, 2, 3 tablespoons of blue paint. Remember, we didn't pick that one. We like, and a real bad check there that I can go back and fix. We like C2. I'm going to check mark C. Good. D says there are 3 tablespoons of blue paint for every cup of white paint. So this is like the reverse. There are 3 tablespoons of blue paint for every cup of white paint. Yeah, that works. That works out well. For each tablespoon of blue paint, there are 3 cups of white paint. For each tablespoon of blue paint, there are 3 cups of white paint. So this tries to flip it, but really that does not work because it's for the 1 cup of white paint, and then we would need 3 cups of the blue paint, or 3 tablespoons of blue paint to work that out. F says for every 6 tablespoons of blue paint, so for every 6, all of them, there are 2 cups of white paint. Yeah, that seems to work out. I like that one. F works also. Sorry if that looks like an X, but I like F. That works out. G, the ratio of tablespoons of blue paint to cups of white paint is 6 to 2. So we're talking about going from blue to white here. Blue is 6, white is 2, and that works out. That's another way we can write this ratio. And then H says for every 3 cups of white paint. 3 cups of white paint. So let me erase out here to get a little space. So if we had 3 cups of white paint, so I would need another one to give us 3, because there's 1, there's 2, and there's 3. There would be 9 tablespoons of blue paint. Okay. I think that works, because if I have another cup of white, I need the other 3 to match up, and that's going to get me 9 total. Okay. So here we're talking about ratios and rates. Sorry, I didn't mean to go back there. Ratios and rates and how they all work out. I'm trying to check off H but H works just like all of the others. Okay, so quick little just once over there with some equivalent ratios. Jada mixed 8 cups of flour with 2 pints of water to make paste for an art project. So we're going to make a table real quick. So on your sheet here, you don't need to write out this scenario, but you're going to make a table. So if you start by drawing a rectangle, and we'll go down the middle here, and then we'll kind of get this set up with a couple of columns. Try to do it as neatly as you can. Don't have to be perfect, but something we can get set up to jot this down, and this will lead us into unit rates also. So 8 cups of flour and 2 pints. So we'll put our cups here. I'll put C for cups, and we'll put our P there for pints, because we're always going to look at our units as we have it there. So I'm not going to start on my first column. I'm going to come over here and say, hey, for every 8 cups, she puts 2 pints. They give us that information, okay? So what if we continue to fill out this table? One of the easiest things to do and the best things to do is to figure out like a unit rate. They tell us how much for 2 pints, but how much for 1 pint? What would 1 pint be? And a lot of you can probably figure out, oh, well, 1 is half of 2, so hey, what is half of 8? Looks like it's going to be 4 cups. So for 1 pint, that'd be 4 cups. So what this will do is it'll kind of help us fill out the rest of this table. So if we wanted to say, hey, for like 10 cups, we're going up like those here for 10 cups. Basically, well, 4 goes into 10 2.5 times, so it looks like I get 2.5. For 12 cups, well, we kind of keep this going. I think there's a relationship between 4 and 12. I think 4 goes into 12 3 times. 4 times 3 is 12. So 1 times 3 is 3. So we would say that's 3 cups there. Let's do 14 and then 16. 16 is one that's pretty easy, because 16 is just the double of the 8. So whatever you have for 8, 8 was 2 here, let's double it, and let's make 4 there. So we can use this to fill out our table and kind of see where we're going. I'm going to stop there, and you'll see on this next one I have it kind of put together this way too. But we can actually answer a couple questions, and you can you don't have to draw this. You already have the table, but you can write either yes or no to these 2 scenarios. One says, if Jada mixed 16 cups of flour with 4 pints of water to make paste for an art project, would the paste be the same consistency? Would that be an equivalent ratio that we would have, gentlemen? So when we look, 16 and 4, yeah, that works out. That's an equivalent ratio because that's the same ratio as our 8 to 2 that we started with in the scenario. 2 says, if Jada mixed 14 cups of flour with 3 pints of water to make the paste for the art project, would the paste be the same consistency? Well, check out 14 right here. And we didn't finish it in the one we were putting together, and I did that on purpose. I wonder if you can write down what 14 is. I kind of want to see if you can do that on your own. But as we answer the yes or no, it looks like 3 is the amount of pints for 12 cups. So that's not going to work out. That is not going to be an equivalent ratio to our 8 to 2, because that's not going to work out just like that. Okay, so see if you can also figure out what 14 would be. Bonus if anyone can figure that out. I'll ask you guys tomorrow, and we'll see what we get with that. So after going some equivalent ratio, real quick run through, let's look at unit rate. And we can fly through this pretty quick, but unit rate you've heard of. I would appreciate if you wrote down this right over here. And you don't need to make the full table, but if you can write that down, rate and unit rate, and we can have these down. Rate, of course, is when you compare 2 quantities, but they're with different units. So the example is always super important. 100 miles in 2 hours. Miles and hours are 2 different types of units, so we're comparing them, how far someone travels in an amount of time. That is a rate. The unit rate is when you figure out per one unit, the denominator must be 1. Okay, so when we figure out per 1 in the denominator spot, we figured out the unit rate. Still has that rate word in there, but it's the unit per 1, okay? You can always pause that to write it down, but I'm going to keep going, okay? So let's figure out some unit rate real quick as we go through this. David can wash 18 cars in 3 hours. How many cars can he wash in 1 hour? Unit rate. Anytime you see in the 1 hour, we're doing unit rate. So I'm going to set this up like an original rate, like a fraction. So David can wash 18 cars. I always write the units out to the side. In 3 hours. Cool. How many cars can he wash in 1 hour? So basically, how many cars can be X in 1 hour? Okay. Well, for some of you guys, this is pretty self-explanatory. When you find unit rate, one thing you can always do is divide your numerator, your top number, by the denominator. How many times does 3 go into 18? Well, if you divide 18 by 3, you're going to get 6 when you divide there. And so that ends up being your unit rate. X is going to be equal to 6, which means David can wash 6 cars in 1 hour. Okay. One other thing I could do, and this is going to be really handy in 7th grade, is you can also sometimes find a relationship. I'm going to back it up just a little bit. But find a relationship between your denominators and your numerators here. So 3 and 1, if I divide 3 by 3, I would get 1. So if you do the same thing to the top, 18 divided by 3, you get 6, and you can get the same answer. So just another way you can find a relationship to find unit rate. So sometimes you get regular unit rate questions, and then sometimes you have to use unit rate to solve a question that's maybe a little bit more extensive. So look at this one. Marcus can wash 21 cars in 3 hours. I always write that down. So cars, he can wash 21 cars in 3 hours. Cool. How many cars can he wash in an 8-hour workday? Oh, so this is a little trickier. So now in 8 hours, how many cars can he wash? Now, on the bottom, I don't have a relationship here. That little tricky way I showed you right at the end of the last slide. 3 doesn't go into 8 evenly, so this isn't super convenient that way. However, we can find a unit rate. So right here with 3 and 21, I can figure out a unit rate. I can say, hey, how many cars does Marcus wash in 1 hour? And then we can use that to figure out how many he washes in 8 hours. So 3, remember I told you can divide. So 3 does go into 21. It goes 7 times. So what does that tell us? The unit rate, Marcus washes 7 cars in 1 hour. That is not the answer to our question because we want to see how many can he wash in an 8-hour workday. So, what's the relationship between 1 and 8? Well, 1 times 8 is 8. So whatever you do to the bottom, we can do to the top. We can multiply times 8. 7 times 8 equals 56. So, that would be quite a lot, but he could wash 56 cars in 8 hours using unit rate to solve another of kind of an equivalent rate or rate question that we have here. Okay, getting close to the finish here. Last thing I want you to have, and I actually don't need you to write this down, but I want to see if you can solve this. You can even pause this and then solve it and then see how you do. You could unpause it and see if you get this, but a little trickier. So it says a student finished 40 questions. So if I did questions at the top, and I wrote it neater. Sorry. Student finished 40 questions in 25 minutes. There we go. How many questions does a student complete in 1 minute? Unit rate. So we have 1 minute to find a unit rate right over there. And then it says how many questions does a student complete in 40 minutes? Oh, what if we also did in 40? So kind of a 2-part question here. So see if you can do an A and B, and then you could unpause it and see if you do it correctly. So for unit rate, what you would want to do right over here, there's not a real clean relationship between 25 and 40. So you can find the unit rate by dividing 40 by 25 to figure out what your unit rate is. And I can make it 40.0. And when you divide 40 by 20, 25 goes into 40 one time, you end up getting 25. When you subtract, you get 15. Bring down to 0 is 150. And 25 goes into 150 6 times evenly. Okay, so this student answers 1.6 questions, and you can get a decimal when you do unit rate, 1.6 questions in 1 minute. Great. So now can we use that and say, how many questions can that student answer in 40 minutes? So to do that, we would just take, what's the relationship between 1 and 40? Well, you multiply by 40. So then doing 1.6 times 40 would be your answer. So we can do 40 times 1.6. Remember to move your decimal out and then over to get this right. 6 times 0 is 0. 6 times 4 is 24. Put the 0, put the 0. 1 times 0 is 0. 1 times 4 is 4. And then we're going to add up. I get 0. Not awesome job yet, but almost 0. 4 plus 0 is 4. And 4 plus 2 is 6. Bring the decimal back in there. And this student, sorry that's a little messy, but this student can answer 64 questions. 64 questions in 40 minutes, okay? So, I know this was a little long, but here's some kind of a crash session on equivalent rates and unit rates. Good job. I believe there's some questions for you to work on after this, so look for that. But excellent job, gentlemen.